My name's Sierra, and today I'm going to be talking about my favorite magical bridge between data and the UI in Android, otherwise known as Databinding. A little about me to get started. I'm a senior Android developer in Cincinnati, Ohio. I really enjoy mentoring young Android developers and being involved in my community. In Cincinnati, I help run Women Who Code Cincinnati, and also I'm a global track lead for Women Who Code Mobile. A fun fact about me is that I really like dogs. And a shameful fact about me as an Android developer is that my personal phone is an iPhone, and I also love it. So what is data binding? So data binding was introduced in 2015 by Google. And what it can do is help you write more concise code, more readable code, and more organized code. It also means that as Android developers, we no longer have to use the dreaded find view by ID function that used to be the only way that you could pull a view into your code so that you could programmatically update how it looked and what it displayed. It also gives us the ability to write logic directly into our layout files, and overall seems very magical. And the reason I call it magical is because it lets your UI automatically update when the data changes without writing any extra lines of code to make that happen. What data binding does is it generates all that code behind the scenes to make that happen for you. But at first glance, it all seems really magical. So with that introduction, you might be thinking, Sarah, it's 2020. This was introduced in 2015. Why are you just telling me about it now? To which I would say it didn't gain a lot of traction until about 2018, which is when you see a big explosion of tutorials and articles and blogs about how to incorporate it and use it in your own projects. Which still begs the question, Sierra, it's 2020, that was 2018, why are you just telling me about this now? To which I say, I am a little fashionably late to this party, and I'm fashionably late to all parties, regardless of if they're metaphorical, technical parties, or real life parties. But also, I think it's a really cool tool, and I think it really makes your code look a lot nicer. On the other hand, I also think that it can be really confusing as a junior developer because it hides so much behind the scenes. And so we're going to go into both of those so that you have this tool for later. So I'm assuming that now you're sold on the idea of this magical bridge. So the first question is, how do you get started? So assuming that you know some things about Android, Android uses a Gradle to hold all the information about the build and its dependencies. And so step one is adding data binding to your Gradle file. And so by adding build features, data binding true enables data binding in your project. And with that, your project is good to go and you're ready to get started. So today I'm going to use a demo app. And so I just want to take some time to get you used to that so that you know what we're talking about when we go through this. So if we just switch over to the actual app, we can see that it's a username and a repository. And what it does is it makes a network call to the GitHub API endpoint. And so if I fetch my commits, it pulls the commits from my repository and displays them in a list field. So with that, we can jump back over and we see that there were two major changes that will link to the data. So we have a progress bar while the call is being made, and then we display our data when it comes back. So we don't have to know a lot about special classes or types in Android to start talking about data binding, but we do need to know that this was built in an MVVM architecture. And so MVVM is model view view model, which is a pretty common architecture for mobile apps. And so it has this important separation of our view layer and our view model, where all our logic lives in our view model and the view only controls the UI itself. So before we jump into the code for that, we're going to talk about the three different kinds of data bindings that we are going to talk about in this presentation. So first is an example of one-way data binding. So in this example, we see Android enabled. So we're talking about being inside the layout files of our Android app. Android layout files are written in XML and are a bunch of views pieced and in a layout. In this example, we'll have a constraint layout. So Android enable is on a button, and it controls whether or not that button will be clickable. So it's our fetch commits button. And so one-way data binding means that the data only flows in one direction. And so in this case, we'll see that it goes from the view model to the UI. So the view model to the XML. And so this is also our first look at what the data binding format looks like. And so to have a data bound variable, we have our Android enabled, which is an attribute on the view itself. So an attribute on the button equals, and then we see the at and curly braces. So at curly braces says that this is a data bound variable. So our next one is a custom data binding. So in this case, we have at visible equals, again, because it's data binding, we see the at curly braces. So one thing that we should notice between these two is that the first one is Android enabled and the second one is at visible. For people that know a lot about Android, they should immediately recognize that visible is not an attribute on any view. Every view has Android visibility, and visibility has 3 states: visible, invisible, and gone, and you can set those on anything. So visible means it's visible. Invisible means the space is still there, but it's not showing, and gone means that it's completely gone and it's not taking up space. So when we talk about Android versus app, we're talking about the namespace of that attribute. So enabled comes directly from Android, and so it's in the Android enabled. App is a custom data binding, and so it's defined inside our app. And so its namespace is app. And we'll go into the example closer, but that's the difference between one-way with Android and the app with one-way. And the final kind of data binding we're going to talk about is two-way data binding. And so this time we have Android text, where Android text is an attribute on a text view. And so this time we see, instead of at curly braces, we see at =, curly braces. And so that tells us that this is two-way data binding. And so two-way data binding means that it both flows from the main view, from the view model into the UI, and also from the UI back to the view model. And so we'll see each of these inside the app itself. So now we'll start looking at the code for this particular app. So to build out your data binding, you have to focus on 3 different things. There are 3 different players to make it work. So we have our layout, which is over in our bottom right, which is again just an XML file. We also have a view, which in this case is a fragment. The fragment is how we're going to control our view in this kind of case. And so in every view, there's onCreateView. It's a function inside that class. And so that is what inflates the layout. And so our onCreateView for this fragment is in our upper left-hand corner. And then we have our view model for our MVVM architecture. And so we have our main view model in the lower left corner. So each one of these has a part that it plays in the view data binding. So step 1 is to tell your layout that it will be a data bound layout. And so to do that, we add these layout tags around the main layout itself. So our layout, which we'll see in just a minute, is a constraint layout, which is down here. And this is the entire layout. So it's made up of this constraint layout with a linear layout, a recycler view, which is just that list view, and our progress bar. So it has those 3 main components, where the linear layout is the top part with the 2 text and the button. The recycler view is the list of commits, and the progress bar is what we see while the data is still loading. So we've wrapped that whole constraint layout in this external layout, and that layout says this is going to be a data binding layout. The next thing we have to do is we have to give that layout access to the data that it needs. And so we have this data element inside our layout. And inside our data block, we have our variable defined. And in this case, the only variable we're giving it is a view model. And so we've given it a name, VM, and we've given it a type, that's main view model from the rest of our project. So now we have to switch over to our view layer. So we switch over to our fragment where we're going to inflate this layout. And so the first thing that we see in our onCreate view is that we create the binding. And so the binding comes from our main fragment XML file, main fragment.xml, and Android creates a main fragment binding because it knows that that's a data bound layout. And so inside our fragment, we can inflate that layout so that we have access to our binding. Then we need to set the variables that we need to give it access to. So inside my view, I have access to both this view, both my binding from my layout and also my main view model. And so the view connects these two things together. And so the first thing that I do, so after I have my binding, then I set my view model. So I have binding.vm equals view model. And so we see that VM from the data block in our layout, and then our view model is where we actually have access to the main view model in the fragment. And then the final piece of this is that we have bindable variables inside the main view model. And so inside our main view model, we see that we have username, which is a string, and right now it's set to Sierra O'Brien, and it has the @bindable annotation on it to let Android know that we are going to use this to bind to our layout. So let's jump over to the code and look at this a little more closely. So inside our main view model, we have all of our variables defined and they're all set to bindable. So we have our username, our repo name, and our loading, our commits. And so now we can go and look at where those are being used. So first thing we know is that our username is going to be data bound to our username variable. And so here is where we can see the first instance of the two-way data binding. What we can see here is that this is an edit text. And so it's immediately set when I open the app to Sierra O'Brien because I've set it in the app. And so it pulls that data straight from my view model into my edit text. However, it is also a two-way data binding, which means I can open my keyboard and type in a different username, and it's going to go back to the view model. And so the view model now has that variable name, that variable username reset to my new username. Similarly, repo name is the same thing. That way I can type in any username and repo name and use this exact same app, and it's data bound. So now we jump down to our button and we see that our Android enabled. So we have vm.fetch commits enabled. So if we jump over to our view model, we can look at this special function that depends on both username and repo name. So we see that is fetch commits enabled depends on validate repo and validate username. And all those functions do is they make sure that username and repo are not blank so that we can send the correct network call. If we notice here, then we see that it also has the @bindable annotation on it. But different from all the other ones is that it has two values passed in. And so those values tell Android that this function depends on these other two bindable variables. So anytime that username updates and gets passed back, then isFetch commits should also be updated. So it will immediately update this one because they all depend on each other. A different kind of way we can use view binding is that we can use it to make our on-click listeners. So we have a button, and every button will have an on-click so that it does something when you click it. And in this case, we see a on-click, which is a Lambda function that takes the view and then has an action. And so in this case, my action is also defined in my view model, and all it does is pulls down the commits. But we notice also in this function is this loading variable that we talked about earlier when we were describing the different kinds of data binding. So we have our loading variable equals true, and then once the result from get commits comes back, then we set loading equals false. That loading variable is data bound to both my Recyclerview, which is just a list view, and Android. And also in the opposite way, it's data bound to my progress bar. That way, when it's loading, the progress bar is visible and the recycler view is not. And when it's not loading, the recycler view becomes visible and the progress bar goes away. So now we can talk about our custom view bindings. So we've seen how we have these couple of variables that are all tied together and make this UI update automatically. So when we look at this progress bar, we see a couple different, the two different namespaces. So we have Android layout height and Android layout width, because those are defined all the time on any view and they come directly from Android. We also see that there are some other ones that have app that don't look like any of the ones that we talked about before. So because I'm using a constraint layout in this particular layout, and constraint layout is a library from Android that you still have to pull in, those don't live inside the Android ecosystem. And so they're also in the app namespace. And so we have app layout constraint bottom, app layout constraint end. And so that can get a little confusing. In addition, we see our app visible vm.loading. And so this is our personal custom view binding. And so we can go and look at how that's defined. So inside my view adapter, I have my one custom view binding defined. And so the first thing that we notice is app binding adapter, and then it also takes a value. And we immediately see that that value is the same as app attribute. So if we look at in our fragment, we see app visible, and inside our view adapter, we see that our binding adapter took in that name visible. So our values will be the name that we see in our layout. And then we have our function defined. And so we have function set visible, and it takes in two arguments. So the first is a view, and the second is the Boolean. So the first thing that you pass into your view binding is the type of views that this binding adapter will work on. And so in this case, I'm passing in view, and view is at the top of the hierarchy for all of these layouts. Everything inherits from view. And so that means that this one will work on any view that I have in my whole app. And then I pass in a variable visible, which is just a Boolean. So I mentioned earlier that every view has a visibility attribute, and it can be three things: visible, invisible, and gone. And so what this does is it takes those three and narrows it down to only two that flip on and off, instead of having to write that logic out yourself. And so I just pass in a true or a false, and it makes things visible or invisible, so it makes them in my view or out of it. So we can expand on this if we wanted to. So this is an example of having exactly one attribute for this binding. But similarly, I could also add a second attribute air and pass that in as well. And so what we can see here is that I can write a custom binding adapter, and so a custom set of data bindings that can depend on more than one thing. And so we can build out really specific functionality depending on what is changing and when. So this is a really simple example of a custom adapter that only flips something that's really common. We also have this list in our app of commits, and so it's a recycler view. Every recycler view needs a layout manager to tell it whether it should go vertically up and down as a list across, or a different one is available, like a grid layout manager that will make them little grids, and a adapter that's going to bridge that gap between the data that you have and each row in your recycler view. And so that's a really common thing that you see in Android apps, because there's a lot of apps display list. And so if you look at my recycler view, you see that I also have an app items, which also ends up being a custom adapter. And so again, in my utils, I also have my Recyclerview adapters. And so for this one, it takes a set of a list of any, and it has that attribute items that we just saw in the layout. And the difference between this one and the last one is that you see that this view only takes the recycler view. So I can only add it to recycler views and not any view like the set visibility. So, and then it takes that list of items, checks if it's not null, and then sets an adapter that I've already provided to my recycler view. And so it got rid of a lot of code for me. When we jump back over to our main fragment, we see that these are the other 2 lines of code that I didn't mention earlier. So the first thing we did was inflate our layout, then we set our view model, and then we see binding.commits. We notice that commits is not the same type as VM because the IDE looks different. And so when we see commits, it comes back to my recycler view. It's actually the ID of that particular view. And so binding.commits gives me that recycler view, and I set my layout manager that I have to have, and then I set my adapter immediately after. And so when my data comes back and I hit this set items, then I can see that it's my adapter is already set, my layout manager is already set, and so it can immediately update my list and display in my UI. So if we head back over to our presentation, one thing that, so when I started this, I said, oh, we can do this without knowing any special classes or types in Android. And that was true. We just had to talk about MVVM and touch on a couple different layout elements. But what I didn't mention is that for my main view model, it extends from a base view model. And that base view model is actually a part of this app and something that I had to do behind the scenes to make this all work without having any conversations about special types of things. So what data binding does and what we had displayed here that makes this app, the UI update automatically, is that that data is able to be observed. And so we didn't have to talk about observing because I hid it in that base view model. And so now we have to talk about it. So when we look at this base view model, which extends view model, which is a part of Android, we also see that it has observable implemented. And so when we do that, we have to add on property change callback and remove property change callback. Those are 2 functions that have to be implemented. And so this is what makes my entire view model observable, and that's what lets data binding happen. Observability means that I can watch for changes. And so by making my whole view model observable, I make those specific data elements observable. This also reflects back on when we look at our username and all those variables, we saw that notify property change. And we have our binding resource, br.username. And so that comes back to these on property changed callbacks. So when I set that data, it notifies that that property has changed, and it triggers these callbacks. It also gives us some other functionality that we didn't have to use in this app. Because I have all those variables are now observable, and I can listen to changes in those for those property I can listen to changes in these binding resource IDs. So I could listen to a change for binding resource.username in my fragment and update something else as I need it. So this gives us extra functionality, but it's also kind of complicated and something we don't actually need. But in order to get rid of it, we have to talk about some special classes. So what can we do instead? And in this case, the answer is we can use live data. So what's live data? Similar to what we just talked about, it wraps your variables in observability, essentially. So live data is a special type that can be observed. So it's data that's live, it's data that changes, and it's data that those changes can be listened to. So what does that mean for us in our code? So if we jump back over to our fragment and our main view model. So the first thing that we notice is that we added an extra line to inflating our layout. So now we made our binding, so we do the exact same thing. We inflate the main fragment, but the second line is that we have to add the lifecycle observer. So every fragment has a lifecycle, and so every fragment has a lifecycle, and so we have to attach that lifecycle owner of that fragment to the UI and the layout. And then we go ahead and do the exact same thing. So we still have binding.vm, and we set our view model that we already have access to, and then we set our commits, layout manager, and adapter, because we're going to use the exact same custom adapter. Now we can look at our view model, and so first we see that we're no longer extending that base view model. That entire class can go away. And so we're extending directly from the Android view model class. Then we can look at our data, and it's a lot cleaner. So now, instead of having that @bindable, view model, set value, field equals value, notify property change, I can condense that all down to a single line and say username equals mutable live data of a string, in this case, Sierra O'Brien. I'm using mutable live data here so that I can change it if I want to change it, versus live data, which is not changeable. So it just gives you mutability. It gives you the ability to change the contents. And so I do the same thing with all of my variables. And so my repo becomes mutable live data of a string, is loading becomes mutable live data of a Boolean, and my commits is mutable live data of a list of commits. One thing we notice that is really different is that fetch commits enabled is now no longer a function. It's a value now. And it's a special type of live data also called mediator live data. And so for mediator live data, I can add my two sources, username and repo, to tell it to update again anytime either of those changed. So previously, we had our @bindable annotation, and then we passed those two values in that said username and repo name to let that bindable function know that when those two, username and repo name, update it, this function also needs to be recalculated. In this case, we use this mediator live data and add two sources that are both also live data to listen for those two pieces of data to change. And so we're really doing the same thing. So let's jump over and look at the code for that. So now we're back in the view model, and now we're using mutable live data instead of @bindable. And so we can see that we have all the same variables defined of the same type, and the other difference is now instead of using an equal sign to set things, we have to use .post value to set those to the mutable live data. In our main fragment, we again see our lifecycle owner, and we just see that we can set that view lifecycle owner directly from the fragment. And then inside our main fragment, we actually have the exact same code. Nothing changed between the old kind of data binding and live data data binding between these two examples. We still have our data block at the beginning of our code. We're still wrapped in the layout. And then we have the exact same layout file. So we have our two-way data binding for vm.username, two-way data binding for vm.repo name, the exact same commits enabled, the exact same list commits. And then also our view adapter looks exactly the same as before. So the only thing that really had to change was we had to take out all those @bindable adapters from our view model and replace everything, and then wrap all of those types with mutable live data instead. And then we had to add that single line to the main fragment, and now we've condensed all of our code down, and now we see how data binding does make our code like more concise, more readable, and more organized. So I think data binding is really cool for all those reasons, and because I think it does make your code look really magical. All I had to do was define mutable live data, pass in a lifecycle owner, and then I could connect it directly to my layout and let the layout and the view model share data between them. So with all that knowledge, why does Reddit hate data binding so much? This is a really valid question because people on Reddit really hate data binding. But my reminder is always, people on the internet hate everything. But there are some really valid criticisms of data binding, so you have to be aware of when you're working with it. So we're going to go over a couple of those, and we've touched on them throughout this presentation. So first, using data binding will increase your build time. There's a lot of code generated between the when you set those variables together. And so that's just going to take a little bit more time. And build times in Android are a really touchy topic, and so that alone will cause people to really hate on it. The second reason is that there can be overuse of custom data bindings and a problem with optimization and efficiency. So we looked a little bit at those custom view bindings that we wrote just to change the visibility. Layouts in Android are really expensive, so we don't want to change the UI any more than we have to. Views in Android already have a lot of attributes. So text views have text. All of them have visibility. The button had it enabled. And so if you click into those, you can look at the source code for what set text looks like in Android. And you'll see that there's a lot of checks before they will actually set your text. They'll check to make sure it's not the same character strings, the character string of characters. So check that it's not the same characters. So we'll go through and do a lot of checks before we'll actually update your UI. Those don't come for free if you write your own custom view bindings. And so in most cases, your custom view binding is not going to be as efficient as the Android view bindings. And so when you can, you should use the ones that are already given to you. For example, if you have something that you want to format a string, it makes more sense to do that formatting before you pass the string into your view binding than trying to write a custom view binding that formats your string and then sets the string. And so that should always be your question. Can I use something that already exists, or does it make more sense to write my own? For example, for the Recyclerview, there's not any data binding that exists in Android already that could do what you're doing there. And so it makes more sense to write your own in that case. But you should always be careful about making sure you write good optimization. So check if it's null. Check if it's the same that's already there so you don't reset it. And that will help a lot with number 2. The final and the big one that I think a lot about is readability and organization. You might remember from when I was telling you what data binding is, and I said, oh, it helps with readability and organization and being concise. That's all true. But I think it's only true when you get to a certain level of Android where you know where that's going to be. What it does in reality is it takes out a lot of boilerplate. And so all that code is gone. And so if you need that extra step, it can actually make it harder to figure out what's going on, because now you have to just know that data in your view model is connected to your UI, even though you can't see any of the code that exists to make that bridge between them. Going further on that, it also makes debugging and testing a little more difficult. When we were using find view by ID and then explicitly calling .set text in our fragments, then we could directly set a line, a debug point on that to see exactly what was getting passed in. Now that set text can be gone if you're using the Android text and just data binding directly from your view model to Android text. And so now there's nowhere to put a debugger on it. It also means that when you have a bug in your UI, it could be one of 4 places now. You can have it in your XML explicitly if you include logic in it. You could put it in a custom view adapter, and there could be logic in there. It could be in your view model if you're have a function that's being called from that. Or it could still be in your fragment, because you can do any of this in your fragment itself. And so now when you have a UI bug, it becomes a game of chance of where that bug is going to be. There's some things that you can do to fight against that, right? First is learn some of the basic attributes of Android. If you see Android text, you know that it's not a custom view binder. If you see Android anything, you know it's not a custom view adapter, because those exist inside Android. Those come from the OS. If you see app in a attribute that you don't recognize, it might be in a custom adapter, and it might be worth looking there first. Other things that you can do to help with that is always stay really consistent. Putting a lot of logic in your XML doesn't make a lot of sense, because it's harder to debug because you can't put breakpoints in your XML. So trying to get it all in one place, and again, minimizing the number of custom view adapters that you use, is going to help a lot. When you put debugging statements inside your custom view adapters, there's no way to limit which view is going to trigger that debug statement. So for example, we had 2 different views that depended on our is loading. So if I have trouble with my recycler view, and I don't have trouble with my progress bar, and I put a debug statement in that custom view adapter, it's going to get called anytime either of those are updated. And so now I need to figure out not only what the bug is, but also which statement goes with which view. And finally, to test some of these with custom adapters, you need full integration testing, which also is an extra step of complexity when you're thinking about how to, not only how to debug, but also how to prevent bugs. And so data binding certainly has some drawbacks, as well as I think is a wealth of ease and benefits. So in closing, I think data binding is amazing, and I think it's a really great tool to have, and I think that it does make your app look nicer once you get the hang of it. I think it's really important to learn how it works, so that if you go into a project that uses it, you have a better grasp of how to debug and use that code. So I will be taking no questions at this time, because this is a recorded talk, but I'm always open to having a conversation about Android and how to use data binding or any other problems you might face in writing your first Android app. The code for this app is available online. So on my GitHub, Sierra O'Brien, it's in a repository, Coin Simple. If you're feeling extra wild, that this is my repository for simple example apps for more than one thing. And so it also has a video linked for simple dependency injection in Android. If you have questions or you want to get a hold of me, you can follow me at Twitter at _Sierra O'Brien. And then finally, if you haven't heard enough, or you want to continue to deep dive into mobile development, you can join Women Who Code on October 24th at 11 a.m. Saturday. And we will be building a Women Who Code mobile app in Flutter. And I would love to have everyone and encourage you all to join. Everyone is welcome in all skill sets. So thank you so much, and I hope to see you guys then.